All right. I can see myself. Oh, I can hear myself too. I'll wait here for a couple minutes for it to start till noon. Hopefully everything's going, looking and sounding okay. I've got the usual mode of communication that we've been working with, which is our phones. Where should I put it? Put it somewhere so it buzzes loudly so I hear it, but it doesn't bother you all. Finally managed to get my green screen lighting working. But then I remembered my headphones are green too, so this is a bright green cord. You just can't tell. I see my captions working. Weird. I have to say this is my first time, personally my first time streaming on YouTube. I've streamed on Twitch in the past, but never on YouTube. But we've got it working. All right, wait one more minute till noon, and then we'll get started. Yep, pilot glasses and pilot microphone. Ready for liftoff. What's the one? Well, thank you all for joining me on our flight today. The weather is balmy. I'm sure that sounded great. All right, we'll start. It's noon. All right. So I am Scott Zimmerman. Chris has mentioned me a few times the past few days. I'm a math professor at Ohio State. I joined the STEM coding team a few years ago now, maybe 3 or 4 years ago. Whenever I started, Chris cornered me in my office and forced me to join. I'm just kidding. Just kidding, Chris. I'm happy with this. So, yeah. Today I'm going to talk about our object tracker. So the object tracker, got it right here. You can find the object tracker by going to, not that one, sorry, go.osu.edu/object tracker. If you go there, this is what you're going to see. So it might look a little intimidating at first, but what this website is p5.js. So if you're not familiar with p5.js, let me open that in a new tab. It is a great free coding tool that works with JavaScript that you can use in your classrooms if you want to teach basic coding things. Most of our other activities are written in p5.js. So there's plenty of opportunities plenty of examples to work with here. Just start coding on your own. If you know what you're doing in JavaScript, it's great to work with. It was designed by artists, so it was made for people to do things very visual, which is what we really like about p5.js. So that's where a lot of our coding is done on this website. But you don't have to worry about doing any of the coding. We're not going to worry about that today. If you want to run the object tracker, what you do is you click play right there. And that makes the object tracker start. So what we have here is our STEM, we call it the STEM coding object tracker. For us, our goal here, one, we wanted to create an object tracker that's free, and two, we wanted to create something that wasn't very intensive. So this object tracker, the point of this object tracker is to track an object. So if you see in this GIF right here, for example, we're going to track the position of this orange ball, and it's going to output some data on the location of that ball. So that can be really useful when you're, I'll explain it more later on today, and more about the activities tomorrow. Today I'm going to focus on just what can you do with this object tracker? How does it work? How do you play around with it? But afterward, tomorrow we're going to talk more about the activities you can do with it. How can you make it useful in your classroom? All right, so again, the link is go.osu.edu/object tracker. And I think I put the link for that in the description for today. So that should be good. All right. All right. So what do I want to say first? I wanted to talk about, so we do have activities for this. Like I said, I'm going to focus on the activities more so tomorrow. Activity 1 for the object tracker is more about what I'm going to talk about today, kind of the how it works, how you use it, that kind of thing. The other thing I wanted to mention before we start too is we wrote a paper on the object tracker. You can find it on arXiv. It's called Methods to Simplify Object Tracking in Video Data. So a few of us worked on this paper, and it's just kind of outlining how our object tracker works. So if you see here, I mentioned there are other object trackers out there. This is an object tracker that it's called Tracker Video. It is used, what you see in this picture is this man who designed it is walking down the sidewalk. He has a piece of red tape stuck to his arm. And so the way this object tracker works is it looks at the image of the piece of red tape, and at every frame it tries to locate that image and see, okay, where in this still frame right here is there this exact picture of tape stuck to an arm. And when it locates it, you can see here it's tracking the location of that red tape, and it's plotting the time throughout the course of the video, the X coordinate and the Y coordinate of the that red tape. So this is a sophisticated way of doing it. Our object tracker is much less sophisticated than that, but it also can just run very quickly online on the website. The way we do it, I'll explain it when we go through it, but the way we do it is based on the color of the object. Okay, so let's check out how this works. So just to start, we're going to use the default video that's right here. We're going to click Analyze this video. And now, what we have here is the very first frame of our video. You see this track bar at the bottom. I can scroll across, and you can scroll back and forth and just see this is throughout the course of the animation. Woo-hoo. So there's a bunch of stuff going on in this picture. Let me try to explain everything that's going on. What our goal is we want our tracker to find the location of this basketball throughout the course of this video. So there's a few things you can see. One thing that is very obvious here is this bright green rectangle. That green rectangle, if you mouse over info, that green rectangle is the region in the frame where the object is tracked. So it says at the top there, the object is tracked only within the green rectangle. So if, for example, maybe there's a smaller region I want to track. I don't want to track everything inside this entire picture. If you look at info, there's a few hotkeys down there at the bottom. W and E change the location of change the size of that green rectangle. So if you have your mouse anywhere in the picture and you press W, it changes the lower left corner location. You take your mouse anywhere else and you press E, that's the upper right corner of the rectangle. Okay, so lower left, upper right. So W and E. This is generally the region in which I want to track my basketball. And I'll show you in a little bit what can go wrong. You know, how do we screw that up? How can we fix things? That kind of thing. All right, so this is our, so the green rectangle indicates the region in which we're tracking things. The white rectangle indicates, this is our ruler. So you'll see the length of the white rectangle is 1 unit of measurement. So let me move it real quick. R does the left side, T does the right side. So right here on the ground, when we were recording this video originally, we placed a meter stick on the ground. So this is 1 meter. Well, when we track our location, what unit, a very important question for our students all the time is what units are we measuring in? We want to measure this in we want to measure this in meters. We want the height and horizontal location to be measured in meters. So what we do, I already forgot the letters, R and T. R for left. That makes sense. And T for right. So we place our mouse at the left end of this meter stick, and I press R. And I place the mouse at the right end of the meter stick, and I press T. Now, this rectangle is 1 meter long, right? So now the program recognizes, okay, if I'm trying to tell you this many pixels in my picture correspond to 1 meter. So now the program understands how long a meter is in this picture. All right, so those are the 2 initial things you want to do before you even start doing anything with it. What region do I care about tracking? I'm going to make it bigger there. And how big is 1 unit, right? If I had a 1 foot long ruler on the ground, then I can put the white rectangle at the left and right side of that 1 foot long ruler, and now my unit is feet, right? This is a meter stick, so now my unit's in meters. All right, so that was what we're supposed to do originally. Our instructions are always going to be here at the top. Resize the green rectangle and white rectangle. See info button for more details, and then click here when done. So I'm going to click there. Now what we want is we want to tell our program what color the object is, right? So the way that this object tracker works is by calculating the color of the object. Every pixel on a screen, has a, I don't want hex code, I want RGB, sorry. There we go. Every pixel on a screen has a certain color. When I type RGB color codes here, if I want to pick the color, say, yellow, I don't want YouTube TDE, thank you. If I want the color yellow, that color yellow, you'll see right below, is 255 red, 255 green, and 0 blue. So if you combine red lights and green lights together, you get yellow. This is the primary colors we learned back in elementary school, red, yellow, and blue. Those work for paint and pigment and things like that. But when you're talking about light, they work in red, green, and blue. All right. So anyway, gold is lots of red. 255 is as much as you can get. Lots of red, lots of green, and no blue. Did I say gold? I don't know why I said gold, not yellow. If I want pure red, that's lots of red, no green, no blue. If I want a little bit darker red, that's not quite as much red, no green, no blue. When you have the lights completely off, that's there's black. No red, no green, no blue, right? That means the lights are all off. If you have all the colors, as much red as possible, all the red, all the green, all the blue, that's white. So every color has a quantity of red, green, and blue associated with it. And that's referred to as an RGB number. So the way that this object tracker works is we tell it a color that our object's going to be. One way to do that is I'm going to click here at manual color select. We're going to say my basketball is kind of reddish. Maybe it's not exactly red. Maybe I want to go a little bit more kind of like reddish orange. That's fine. I can use this nice color selector to choose reddish orange right there. Okay, there we go. So I've got my reddish orange color. This has an RGB associated with it. It's 248 red, 60 green, 13 blue. You can think about this. Now let's get into, three-dimensional vector calculus. I'm kidding. I'm not going to go too deep into that. But you can think about this as kind of a three-dimensional coordinate, kind of like an XYZ coordinate in space. And then when you think about this as a coordinate 248, 60, 13, now all of a sudden you can talk about the distance that this color is away from another color, right? So the way that this object tracker works is it looks at each pixel and it asks, is this closer to being orangish red? Or we can pick the color for the background too. Is it closer to being black, right? And if the pixel is closer to being orangish red than it is to being black, the object tracker is like, that's part of the object. If the pixel is closer to being black than it is to being orangish red, the object tracker says, oh, that's part of the background. That's not part of the object. So if you notice, we picked this orangish red for the object. We're picking black for the background. I'm going to click here. And the object tracker, now it's lighting up all the pixels that it thinks are part of the object. It's making them white. Sorry, this is my blanket, my nice cozy blanket. I'm in my basement, so it's kind of chilly down here. Yeah, so it did a good job. We did a pretty good job here, right? The object tracker did a pretty good job saying, hey, this is part of the all these white dots are part of the object, part of the basketball, and there's no white dots over here indicating part of the background. Okay? So that's the idea. So let me go back. It asks, is your object highlighted correctly? If so, click track my object. So if it right now did a good job, we could track the object. Let me show you what happens if we do a bad job. Okay. I'm going to make a real bad mistake. Let's say I mess it up and I want my object, I think the basketball's about that color. And then I think the background is like a green screen. Let's see what happens. Ugh. That was really, really, really bad. So now the computer, you can see my FPS in the upper left is dropping like crazy. Now the program thinks that everything is part of the object, and if I try to track this, it's going to be really confused. So let's just clear data and restart. Let's start over. Okay. So let's go back to a good job. Phew. That's one way of having it choose the color. If you don't want to do it manually and you don't want to try and guess what the color is, like I was guessing it's kind of like orangish red, if I don't want to guess orangish red, another way of deciding what the color is this click to choose colors mode. And so what this does is it says click 3 points on the object. Here we go. 1, 2, 3. I just clicked 3 times on the ball itself. And now what the program just did is it took those 3 RGB values and it took the average of those. All right, and now somewhere in the background, actually you could see it in the console here in the lower left. We got it here so it's not totally secret. I clicked at the coordinate 112, 37 and it got the red, green, and blue of my first click, the red, green, and blue of my second click, the red, green, and blue of my third click. Oh, I'm in the way. Sorry. Over there. The red, green, and blue of my third click. And now, behind the scenes, the program's averaging those values and saying, okay, here's my average color of the object. Now I'm going to click 3 points on the background. Boom, boom, boom. Wow, I did way better than I thought I would. I thought I was going to mess that up. Now it's, wow, that's cool. That's the best I've ever done it. Now I've got a really good approximation for the actual basketball itself. Okay? Let me do it a little bit. Let me do it one more time. I want to screw this up. There we go. Okay. Here I clicked a few times, but I didn't do a great job. I think I clicked too much in the shadow on the basketball, and I clicked too many light spots on the background. So you can notice here the basketball is really highlighted, but we've got these other dots around here and some on the ground right here that the program thinks are part of my object. And that's because the numbers it got for the color of the basketball and the numbers it got for the color of the background are a little bit too close to each other, right? They're not extremely far away. They were a little bit too close to each other, and so the program sees some of the light spots on the ground as like, oh, those are kind of the same color as the object, even though we know it's not. So how do you fix this? Well, we came up with a way to fix this. One way to get around this is up here in the upper right. This is the only thing I haven't talked about so far. It says color distance mode. And I'm not going to go into the details about it. If you want to know the details of it, we had two different ways of calculating how far a point is away from being the color of the object or the color of the background. One of them is this color distance mode I mentioned. The other one is called brightness agnostic method. All that means is it kind of not averages out, but it normalizes the color vectors, whatever that means, but it normalizes the vectors in a way that so that it doesn't take into account brightness anymore. If you notice, like, dark red is 153, light red has a lot of green and blue in it. So even if you've got an object that's red, if it's really lit up, our object tracker is going to think it's got a lot of green and blue in it. So that's no good. All right, so what the brightness agnostic mode helps to adjust for the brightness. So the way you switch color modes is you look at, okay, color distance mode. That one's not great because it's seeing too much of the background as the object. Click on it. Boom. In brightness agnostic mode, everything's good. So the nice thing about this is if you're tracking, you picked a color and it wasn't great, try switching to the other calculation. Maybe the other calculation will be better. Maybe it'll be worse. So in this case, based on this video, seems like brightness agnostic mode is the better way to calculate it. So the moral of the story is that this button in the upper right can help fix some of our mistakes. Okay? All right, so we are at the point now where we're ready to track the object. So what we did so far is we figured out how to choose the color. We figured out how to tell the object tracker what the color of our object is. And we used manual color select to do it, or we used click to choose colors as a way to do it. And now we're going to track the object. So I click track my object, and now it's going. Notice nothing's going on. We don't see any weird stuff going on because the ball has not yet entered the tracking frame. Now I hit play. And there we go. Now something's happening. Oh, I think I made this too short on the top. Oh well. I think I can fix it on the fly. Make that a little bit taller. There we go. If you notice that things are bad, you can always pause and kind of reset, so like change the sizing so it's good going forward. Okay. Anyway, what's happening here, what you see going on here, the white again indicates what the program thinks is part of the object. The pink is like the center of mass of all these white dots. You take all the white dots, you average out their locations, that's the pink dot. So that's kind of the center of our object. That's what the tracker sees as the center of our object. And this green path right here is what the tracker sees as the previous path of the ball, right? The path of the ball up to this point. And notice this errant dot right here. That errant dot happens because that occurred because the ball wasn't completely in frame. And so when the ball wasn't completely in frame, it got a bad reading of where the ball was. So not a big deal. Tomorrow I'll talk more about how do we worry about that. So I paused it. That was this button in the lower left. I'm going to unpause right now. Play. And it's tracking the location of the object throughout this whole process. Going. Still going, and boom. It got to the end. Oops. I don't have anything Embarrassing there. It got to the you can see all the data. And anywhere you see data 36, 34, that's from running the object tracker. What the program just did is it's now trying to automatically download. Don't worry, it's safe. We're not trying to give you a virus. Automatically download a CSV file. CSV stands for comma separated values. That's just one format data can take. And Excel understands, or Google Sheets understands how to read that, or LibreOffice, whatever spreadsheet software you want to use. So this is it's data 42 right now because this is the 42nd copy of it in my downloads folder. So I'm going to hit save. There it is. I'm going to open it. I'm going to convert, so Excel is going to convert large numbers into scientific notation. No, I don't want you to do that. And you see here, this is the output of our data, the output of our object tracker. We've got one column here, which is labeled T. That column is measuring in seconds. So our video here, I don't know if it says it anywhere. It's in the code here on the left. Our video is in 240 frames per second. So if you've got a smartphone, you can record in 240 frames per second. It's what I think it's slow-mo, not super slow-mo. I don't remember, but don't quote me on it. If you record a video and it's in a different FPS, you can just adjust it here and put 60. If it's a 60 FPS or 30 FPS, whatever speed your video is. FPS is frames per second. Okay, so this is measured in seconds here. And the X location is measured in meters. The reason we know it's meters is because at the very beginning we set it up to be meters. And Y is also measured in meters. And you notice at the beginning our data says object out of range, but that's okay because if we go back to the beginning, it was out of range. At the beginning, our tracker didn't see our object because it was outside this green rectangle right here. And then eventually, after about 0.229 seconds, the object finally, and I guess I should have converted it to scientific notation, or at least had it round it. The object finally enters the frame and starts being tracked. Okay. So the X location of the object is given here. The Y location of the object is given here. And here's a whole bunch of data that you can work with. So what I'm going to talk about tomorrow is these activities. What do we do? What's a good thing to do with this data? What we'll talk about is one of the activities is going to be calculating velocity. How can we use this chart we have right here to find the velocity of the ball? What do we know? What does that tell us about the acceleration of the ball? Can we use the information that we got to figure out what the value of G is, the gravitational constant, right? This is in meters, this is in seconds, so we should be able to calculate, ideally, negative 9.8 meters per second per second. That's the gravitational constant due to gravity. Gravitational constant due to gravity. Acceleration due to gravity. All right. So that's what we can do. What are some other things that, you have to worry about? Well, what if this is one thing I wanted to show. What if my range is too big? What's going to go on here? Well, it's going to get confused and it's going to think she's part of the object. And so now it's averaging out her location, the object's location, and this is the path of the object right here. Not good. So we realized that was a mistake. Well, let me resize it so she's not part of it. Clear data and restart. Try it again. Right. Ooh, oh, phew, her finger didn't enter the frame. So that's all about how the object tracker works. I want to say one more thing that was at the beginning. We actually have, so if I uncomment that, there's another video we have, if we want to just skip the opening screen and we go straight here. This is another video that we could use to track our object, to get some data. Here, the object we want to track is this blue roll of painter's tape, and 1 meter is from here. Oop, boy, that's definitely not what I want to do. 1 meter is from here to here-ish. There we go. All right, so that's 1 meter. That's our unit. I'm going to move our window a little up because what this guy's going to do is throw the tape in the air, and I don't want his arm to accidentally get tracked. And what I want to do, well, here's the object. It's kind of a bluish tape, so let's say it's like blue. The background is not black. The background is closer to white. So click here. There we go. That does a pretty good job of tracking the object. We hit track my object. There it goes. The really nice thing about our object tracker is it's only worrying about what happens. And there we go. Here's data set 43. Take a look at it. Looks just like the other ones. Oops, convert this time. Looks just like the other one. Pretty nice data for us to play around with. What was I going to say? Oh yeah, the nice thing about our object tracker is it only cares about the color. It doesn't care about what the object looks like. So for example, this roll of painter's tape keeps flipping around, and now it's a circle-ish, and now it's just a line, and now it's back to a circle, and now it's a line. It doesn't, our object tracker does not care what shape the object is. It just cares about color. So it makes it really nice when you're dealing with oddly shaped objects like that. So one last thing. Let me restart this. Just hit play to reset the whole thing. So this whole time we've been using our default basketball video. You can also, I should have had something prepared for this. Maybe I'll have it for tomorrow. You can also upload any GIF you want, and GIF of rocket. I don't know, this is not going to work well, but let's see how this works. No, that's a JPEG, not a GIF. I say GIF, not GIF. You got to deal with it. There's some strange things happening here. Anyway, whatever. I've got it on my other monitor. I was going to find a picture, a GIF to upload there. But anyway, Chris programmed this nice program here, this nice app. If you click on this, to access the STEM Coding Video Tracker, right-click this link, select Open in New Tab. Here we go. What I can do, I'm not going to do it because I don't know what kind of videos I have, but you can, if you record a video on your phone and save it, transfer it over as an MP4 file, that's a file type, or an MOV file, then you can click here, you can upload it to this website, and it'll automatically turn it into convert it to a .gif, to a GIF image file. And then when you have that GIF image file, you can upload it here and you can use it on your own. So that's a great activity if you want to, have your students go from start to finish of creating an experiment to doing the activities I'm going to talk about tomorrow. Have them record their own video. Get a basketball in your classroom, get a solid color wall, like maybe you have a white wall in your classroom, set up a camera and have them toss the ball or maybe drop a rubber ducky or whatever. Something, well, rubber ducky wouldn't be good against a white wall. Some brightly colored object, maybe a dark object. You have them drop it in front of an American football would work. Have them drop an American football in front of a white wall and track the data. They record it, they convert it to a GIF, they upload it here to this object tracker, then they can track, get this whole nice data set about it. Okay? So that's about it for today. I'm checking people should avoid. Oh, yeah. Chris just said in the chat, make sure you avoid, I forgot to mention this, unfortunately, this object tracker doesn't work great in Safari or Firefox. Sorry to say. So you're gonna have to use either Chrome or Microsoft Edge for it. So yeah, or if you can find another browser that works. And have you tried Opera, Chris? I don't know. I haven't tried Opera. Does Opera still exist? I don't even know. Or if you have like a really old computer, maybe I wonder if Netscape Navigator would work. Probably not. I doubt that has been kept up to date with anything that would be useful on the internet. All right. That's all I've got. I don't see any other comments on Discord or YouTube. Chromium would work. Okay, Chromium. Right, because it's Chrome-esque. So Chromium would be good. Okay. Well, that's it. You just not Safari or Firefox. I'll be back tomorrow covering the activities for the object tracker. If you have any questions, feel free to leave them in the comments below. Put them on Discord, whatever you want to do. I will see you all tomorrow. Thanks for joining.